All right, is the following correspondence a function? No. Okay, why, April, why? All right, I'll try to tell you. All right, when you're looking at the picture, they are showing the numbers on the left and then arrows drawn to numbers on the right. So the left side here, these are your x's, which is also known as the domain. And then these guys over here are the y's, which is also known as the range. Okay, and 1 to 1 simply means that every number on the right corresponds to only one number on the, one number on the left, sorry about that, corresponds to only one number on the right. So the 9 is definitely only going to the 13. And then the negative 10 is going to the negative 10. But then when you get to the 15, 15 is going to both the negative 17 and also to the negative 10. And if it's a function, functions are 1 to 1 as far as every element that is in the domain can only go to one element in the range. Now it's possible to have like 9 and negative 10. Let's say that they drew the arrow from 9 to the negative 17 and also the negative 10 to the negative 17. That is still a function. As long as each x goes to only one y, it doesn't matter which y it is, every single one of those x's could go to negative 17, or they could all go to 13, or they could all go to negative 10. It doesn't matter as long as they're only going to one of them. But this negative 15 right here maps over to both the negative 17 and the negative 10, so therefore the answer is no, it is not a function. All right, I'm going to go ahead and do another question. I will do number 7. This one also asks, tell whether or not the relation is a function. Basically, it's the same thing, because if you were to draw it out, you'd have x is negative 4, x is negative 1, 4, and 7. And then they've got negative 9, 6, there's another negative 9, and then a 7. So the arrows would be negative 4 goes to negative 9, negative 1 goes to 6, 4 goes to negative 9, 7 goes to 7. And every single one of your x's is different. I got a negative 4, a negative 1, a positive 4, and a positive 7. So, you know, if there had been one more point in here, well, the answer to this one is yes. Yes, it is a function, okay, based on that. But if they had added one more point that was like negative 6, negative 9, or sorry, why did I say negative 6? Sorry, negative 1, negative 9. Then you'd have negative 1 again, and now you'd have that arrow. So you'd be showing, just like before, you'd be showing negative 1 going to the 6 and negative 1 going to the negative 9. So that would be no, it's not a function, because this x right here is the same. Probably should use a brighter color here. This x right here is the same as this x right there. And they have two different y's. So that's a big no. And that's number 7. So those two questions asked about whether it is a function or not a function.